buttons, and then
Yeah, now we're going live on YouTube, everyone.
people are still arriving. So. Okay, shall we start?
Sure.
Okay, so hi, welcome everyone. So before we start, just a quick reminder. Of course, as usual, now you know you have to follow the code of conduct, and especially you have to use your real name. And please do not share the link to this webinar to other people. So it's my great pleasure to introduce the first invited talk of this year Crypt. And our first invited speaker is Alice Silverberg. So I guess all of you know her. Alice is a distinguished professor of mathematics and computer science at the University of California, Irvine. And I think that being a professor of mathematics and computer science is something very important here, because most of Alice's contributions result from an interaction. I have to say, I think a deep and fruitful interaction between mathematics and computer science. Alice has worked on number theoretic cryptography, on lattice-based crypto, on primality proofs, on fatal tracing, and she's best known for having introduced torus-based cryptography, and also, together with Dan Bonnet, she introduced the use of multilinear maps in cryptography. And she also co-invented the first fully hierarchical ID-based crypto system. So Alice has received a lot of awards. For instance, she's a fellow of the American Mathematical Society and a fellow of the Association for Women in Mathematics. So Alice is a great mathematician, a great cryptographer, but she is also a great advocate and promoter of equity and fairness. She has initiated many efforts to eliminate all kinds of discrimination and to make our professional organizations and communities more welcoming and more inclusive. And I strongly invite you to read her blog about Alice's adventures in Numberland. So Alice, thanks a lot for all your scientific contribution, of course, and also for your deep commitment in favor of equity and fairness. And so now the floor is yours.
Wow, great. Thank you so much for that really kind introduction. And I also want to thank all of the people who are here for showing up. And that's a lot more people than I expected. So great. Thanks. So I'm hoping that everyone is coping well with the pandemic and managing to keep yourselves and your families safe and healthy. As I know that with the pandemic, some of us are stressed out. You know, we don't know whether we're going to end up on ventilators or whether we should be drinking bleach. And my goal today is to keep this talk light and hopefully also interactive. And we'll maybe try to figure out how to do that as we go. So there's a tale of two talks. There is a recorded talk, a 44-minute recorded talk on the website. It included some things about multilinear maps and torus-based cryptography, and some stories that I won't tell today, because today I'd like to talk more briefly and try to leave some time for some discussion so that we can all maybe talk about a few things, and maybe I'll make some suggestions for things we could talk about. I'm going to try to monitor the Q&A window, so please submit questions there. If I'm ambitious, I might try to answer some of the questions during the talk, but if not, I'll leave them until I'm done speaking and then try to get to at least some of them then. I won't monitor the chat window. I thought there should be a chat window. There probably is one, I just can't see it. But you can use that to say things like speak louder, or we can no longer see your slides, and hopefully Anne or Yuval will let me know about that. So if you can't hear me or you can't see the slides, let me know, because I can't necessarily figure that out otherwise. So I want to try something. I'm curious as to how many of you have already viewed the recorded talk. So please use the raise hand feature in Zoom now if you watched the recorded talk. Oh, wow, some people actually did. My goodness, yeah, so great. And I have a way to lower hands. I will now lower hands. Wait. Oh, there are lots of them. Okay, that's surprising. Okay, I think I lowered hands. Okay, so now, could you also now use the raise hand feature if you did not watch the recorded talk? And I'm asking that so I can see how many of you are actually awake and listening to me. Oh, good. Okay, great, 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 great. That's enough. Wait, you're filling my whole screen. All right, good. All right, so I will now try to lower all hands. Okay, great. Thanks very much for doing that. So we see how that works. I don't have the ability to poll, but I do have the raise hand ability. Okay. So feel free to submit questions in the Zoom Q&A window at any time. Whoops, I have to go back to my slides. Okay, so what's the use of a book, thought Alice, without pictures or conversations? I think of as what's the use of a talk without pictures or examples? So today what I'm going to do is show some pictures and tell some stories to give examples of lessons that I've learned that I wished I had learned sooner. So first of all, why did I call this talk Mathematics and Cryptography, a Marriage of Convenience? Well, mostly that was to get you to come to the talk. But someone asked, does this title mean that I view mathematicians and cryptographers as disjoint sets? And the answer is definitely not. As far as I'm concerned, cryptographers can be mathematicians or computer scientists or engineers or whatever. They might be in more than one category or in no category. So I started out as a mathematician, and I now consider myself to be both a mathematician and a cryptographer. So someone thought it should be a menage a trois since it should include physicists, because we now have quantum and post-quantum cryptography. And someone else told me he really wanted it to be an open marriage because it should include lawyers and policymakers. So given the importance of cryptography, there's a need for cryptographers to communicate with people who have different backgrounds and goals. So I always try to ask myself, what can I learn from this? So this talk will mostly be about learning to work well together through community, communication, curiosity, doing the right thing, and making good use of experts. So maybe it's perhaps a bit like marriage counseling. We live in a small world and we depend on each other, and maybe we're more likely to survive and to thrive if people learn to play well together. So I think that there are good reasons to bring more mathematicians into the cryptology community and make the community more welcoming to mathematicians. In particular, for crypto systems that are based on the presumed difficulty of some problem from number theory, we might have more reason to believe the system is secure if number theorists in the right field have tried hard to solve the problem and failed. So I found the cryptology community to be really extremely welcoming to me when I first started coming to IACR conferences, which was about 20 years ago. So in 2001, I went to Eurocrypt in Innsbruck, and then I went to Crypto in Santa Barbara. And at Crypto, a group of us were standing around and someone introduced me. And someone in the group said something like, oh, we already know her, she's an old friend. So I said, well, you must have me confused with someone else. I went to Eurocrypt this year, but that's the first place that we would have met. And he said to me, but that makes you one of us. You're part of our community now. And you know, it was actually one of the most welcoming things I think that anyone has ever said to me. So those of you who are joining the IACR for the first time, welcome. You're now part of a community. Well, by AsiaCrypt 2001, I was one of the gang. You know, curiously, I think it's only more recently that cryptographers have told me that they don't think of me as a cryptographer. So I hope the community doesn't get less welcoming. So with the pandemic, it might be harder to maintain a sense of community, but it's probably even more important. And I hope we'll think deeply about how to maintain and strengthen a sense of community. So for the past 8 years or so, I've been co-organizing a series of conferences and workshops designed to bring together computer scientists and mathematicians to work on cryptography problems of common interest. So mostly questions about fully homomorphic encryption and lattices and multilinear maps in cryptography. So from this, I've learned some things about community and communication. So one thing I learned is that boat trips are a great way to foster community. So especially if you get to see blue whales and dolphins and sea lions. No, those are the cryptographers. The sea lions are on the right, and windmills. And here's one more of a conference at UCI. And well, so one thing we found is that it was important to bring together the right people. So if the goal is to solve a certain problem, I think it's useful to bring in the top people in the field. So if the problems require a good knowledge of lattices, we invited experts in lattices. If the problems required understanding elliptic curves, we invited experts in elliptic curves. And the way I ended up working with Hendrik Lenstra was that I got interested in fully homomorphic encryption. And I realized I just didn't know enough about lattices and I needed an expert. And this led to a long and productive collaboration. And on my very first cryptography paper, which was on trader tracing, Judy Walker was an expert in algebraic coding theory, and Jessica Stadden had the expertise we needed in security and cryptography. So bringing in the experts is something that I think is important. But among the biggest obstacles to getting people from different scientific cultures to work well together, I think are communication problems. So particularly differences in vocabulary and jargon. So one challenge as a conference organizer was getting the speakers to keep in mind who their audience was. So I'll just give a simple example. So we write WW2, but we say World War II. We would never say WW2. You know, it has 7 syllables. Well, World War II has only 3 syllables. Now, I actually have a dear friend who drives me up the wall because he says WW2. Now, don't say that. It doesn't make any sense. I think, you know, you can agree with that, hopefully. But similarly, why say LWE when you can say learning with errors? They actually have the same number of syllables, count them. So I know mathematicians who tune out or get angry during cryptography talks because of all the abbreviations. It helps a lot to spell things out or give a short explanation, even if it would take more syllables to say it. You know, when you're saying it, try to say it in a way that takes into account who your audience is. So similarly, I know computer scientists who get frustrated at math talks by the very specialized terminology that they don't know in some cases. So it would also be good if mathematicians were to write more survey papers acceptable to non-mathematicians. And I have plans to write some more of those that I hope I'll get around to before too long. Well, in the recorded talk, I talked a little bit about torus-based cryptography and the Cayley crypto system and how it got into the television show Numbers. But today, instead, I'm going to tell you a different story about it. So Cayley and XTR, which I also mentioned in the video, use finite fields that have q to the 6th elements where q is a large prime power. So you have to know about finite fields that aren't just prime fields to do Cayley. So there was this computer scientist who told me he was going to do me a favor. He was going to do a good implementation of the Cayley crypto system for me. So I asked him how much mathematics he knew, and he said he had a very, very strong math background. But he was running into problems implementing it, and he told me that the equations that we had in our paper had to be wrong. They couldn't be right because the implementation wasn't working. So we talked for a while, and eventually I asked him to tell me about the finite field with 4 elements. And he was maybe a bit offended by the question, but he said, well, the finite field with 4 elements is just the integers modulo 4. So he didn't realize that the integers modulo 4 don't form a field. So this was a problem. Clear communication is important, I guess I would conclude from this, especially with people in a different field or a different culture. So I should have listened to him more closely instead of going on and on and on about finite fields and assuming that he understood. So a relationship is a negotiation. You have to figure out what the other person is thinking, basically by asking a lot of questions and being curious. In the end, he probably wasn't the right person to implement Cayley. There are plenty of cryptographers who know how to implement finite field arithmetic. But following up on this, Stephen Galbraith recently wrote in his Elliptic News blog And I'll quote him, "A long time ago, when pairing-based cryptography was new, cryptographers who did not fully understand the mathematics of pairings would sometimes make mistakes. Indeed, such cases apparently still happen." And he said that if we fast forward 15 years to the present time, the same is happening today with isogeny-based cryptography. So the advice I give to students who come to me, who want to do mathematical cryptology, is if they're computer science students, I tell them to learn as much mathematics as you can in school and university, preferably by taking courses. And if they're mathematics graduate students, I usually say do a math PhD thesis, not a cryptography one. Now, in both cases, it's the same reason. The reason is I think it's easier to learn the mathematics deeply in school and learn the cryptography later than it is to learn the mathematics later. So after observing conflicts for a while, both inside the cryptology community and outside it, it seemed to me that a lot of conflicts were coming from failures of communication, but especially in thinking one can read the other person's mind, and from assuming that others can read your mind and know what you're thinking and maybe know why you're so angry with them. So keep communication channels open. We should work on maybe good ways to communicate. So I just want to talk a little bit about curiosity. So be curious and open to opportunities. That's actually something I think the cryptology community does really well. So here's a story that I told in the recording, so I apologize to those of you who have heard it already. So I was visiting the Institute for Advanced Study in Princeton in the fall of 1995. And I was put in this horrid, dark office in the attic of Fold Hall. It had broken furniture, no air conditioning. And when I arrived, it was a sweltering summer. And I felt like Cinderella and was feeling terribly sorry for myself. So the room was by itself on the top floor. It was really hard to find. And I was surprised when one day there was a knock at the door. And it turned out to be a grad student in computer science who had trekked over from the university to track me down and ask me questions about abelian varieties. So this was someone who was curious and open to opportunities and knew that it's worthwhile to talk with the specialists in the field. And that's how I met Dan Benet. So be curious. Curiosity is a very useful thing. In particular, be curious, not furious. So I stole this phrase, or I got this phrase from a book by Dorothy Hellman and Marty Hellman, the same Hellman from Diffie-Hellman. And they actually use the wording, get curious, not furious. I highly recommend their book, A New Map for Relationships, Creating True Love at Home and Peace on the Planet. So the book talks about the importance of listening. So if you're curious, you'll talk less and listen more. I think that would be something that would be really useful nowadays. There's a lot of talking going on and maybe less listening than we would like. You think of committee meetings you've been to, for example. But you learn a lot more by listening than by talking. And while we're on the subject of listening, I think it's good to listen to advice with an open mind. I'll be giving you some advice later, so I have an ulterior motive in saying this. Okay, so I'll tell you another story that I think this one also was on the recording. So Dan Benet, Carl Rubin, and I were working on a paper. It happened to be about composite order groups to use in pairing-based cryptography. Now, Dan wasn't being as responsive as I wanted him to be. And eventually he explained to me that the reason was, his highest priority is always the paper with the next deadline. So if I wanted him to work on something, I had to give him a deadline. Now, sometime later, Victor Miller and Neil Koblitz asked me to contribute an article to a special issue of the Journal of Number Theory. I think it was on the occasion of the 25th anniversary of elliptic curve cryptography. And they said there wasn't a precise deadline yet, maybe late spring or summer. And later they said, well, the deadline will be in the fall at the earliest. So these were not the sort of strict deadlines that Dan was used to. These were soft mathematician deadlines. So in October, I asked Neil for a firm deadline that I could tell to Dan. And Neil said, well, the end of October is clearly too soon. So let's say something vague, like in a few weeks. Well, I didn't think that was going to work on Dan. So I told Dan, we have a deadline of October 31st. Well, he worked really, really hard on that paper. Now, on October 31st, we ran into a small issue for which we needed a little more time to deal with it in the right way. But Dan said, we have this deadline. The paper's good enough. Submit, submit. Well, knowing that we didn't really have an October 31st deadline, I told Dan that I had asked the editors for an extension, and Neil and Victor gave us an extra 24 hours. Well, so in those 24 hours, we easily dealt with the issue and we were able to submit a polished paper. So to this day, I felt terribly guilty for misleading Dan. And he doesn't know the story unless he watched my tape talk, which probably didn't. So please don't tell him. But this brings me to the question of whether having tight deadlines and page limits is actually a good thing. So let me tell you one more story. So when I was first moving into cryptography, someone asked me to look at a paper that he had submitted to Crypto. And he probably jokingly said that if I found any typos, he would pay me $2 per typo. Well, I found something like 35 problematic statements in the paper. So many were actually what I considered to be more than typos. They were actually mathematical mistakes, in my opinion. Now, I didn't collect on the debt, but what I found really interesting was that in my experience with math papers, if there are a lot of typos or mistakes, that's a serious red flag. I know the result's going to be wrong. But what I learned is that smart cryptographers can write papers with a lot of typos or mistakes, but where the main result is robust. And I was really surprised by this. But then there's the question, is this a problem when papers have mathematical or typographical errors? So I think it's important to get things right. I think it would be better for science and the profession if published papers were polished and correct, and if the literature were reliable. Also, the mistakes make it hard for mathematicians to read. So if mathematicians and others are turned off by what they view as a sloppy paper, or if we're worried about the correctness or security of the system due to the mathematical mistakes, that could be problematic for the field. So why are there a tortoise and a hare in this picture? So I think of it as a cultural difference between the fields. So it's like the tortoise and the hare. Is fast but sloppy better than slow and careful? Is it better to have rapid publication with necessarily limited review, or to have more careful refereeing? So here's a question for you that I hope we can talk about when we have a discussion in a couple of minutes. Can we maybe try to get the best of all worlds, fast publication and correct, well-written papers? And what would it take to do that? Should we encourage more journal publication? And what would we have to do to change the reward system so that good editors and referees are appropriately rewarded for good reviewing in a timely manner? So I'm a great believer in making good use of experts and doing things like posting preprints online and sending them to experts for their feedback before publication. And it seems to me that some of the greatest gaps between the mathematics community and the cryptology community have to do with publication, including what is acceptable behavior. So for authors, reviewers, editors, what's ethical and what's best for the field. And Rainer Broker says, how about the ants model? Now okay, so that's interesting. So I guess my worry about that is that they're sort of going the wrong direction. They're moving towards, the thing that I don't like. But yeah, but maybe we can talk about that a little. We can actually unmute your mic later and we can ask you if you're okay with that, Rainer. Okay, so I'm almost done and ready to open that up. Okay, so when people ask me, so this is the advice that I was going to give you. I warned you I would give you some advice. When people ask me for advice, here are some of the points I try to get across. And I'm happy to explain what I mean if there's interest. So many problems I think could actually be avoided if people simply behave professionally. So I found people are more likely to do the right thing when they ask themselves, is this professional? Is this ethical? Is this legal even? Put in place good practices and policies and hold people accountable. Train people in best practices for things like refereeing papers, hiring and promotion, for teaching, for choosing interns, for choosing students. So there's actually, in the recorded version, there's a story I give about IBM and about Don Coppersmith. And I think it gets into some of these things. And I guess also in my Alice in Numberland stories that I'll talk about in a second. Make the rules of the game clear. Don't change the rules in the middle of the game. Ensure everyone has an equal opportunity to play the game and win. So what I mean by this is sometimes there's an inner circle that knows the rules and knows which rules they can break and get away with, or which rules they can change. And they, change them without telling anyone else. And that inner circle has an advantage. And I should say, I'm glad to see that the IACR and other communities are thinking about issues related to fairness and accountability and ethical behavior. So I'll give a plug here for my Alice in Numberland stories. This is essentially my memoirs, but it's also about things like fairness and accountability. And there's a link from my website if you don't get this link. Shahed Sharif pointed out to me that kindness is a superpower. I don't know if Shahed is in the audience today, but kindness works a lot better than getting angry. I wish I'd realized that a long time ago. So given that cryptography assumes an adversarial situation, one could argue that it's counterintuitive to want cryptographers to be kind, but anything we can do to make our communities more humane will make them more welcoming, it's going to make them more welcoming, it's going to make us healthier and happier. So we're all in the same boat, especially now. It's an interconnected world. Let's try to make it a better place. Remember to eat well, get enough sleep, stay healthy and safe. And I'm going to leave, I guess, as my last slide, some food for thought and possible topics for discussion. So should we have, as I said, more journal articles, fewer papers with deadlines and page limits? And what would it take, what would be suitable rewards for good editors and referees? Would we pay them? Would we have an award for a good referee or award for a good editor? And about conferences, so both to maintain a sense of community and for the environment, perhaps we should think about whether there should be fewer conferences, but we should stay at them longer and make them count for more than just getting a paper published. So don't just fly in for your own talk and leave right after it. One thing I found seemed to be successful are semester-long programs with week-long workshops as a good way to build community. So an example would be the Simons Institute for the Theory of Computing, which is one of the places that does that. Also, I should say one thing that deters mathematicians is actually the cost of attending cryptology conferences, especially the registration fees. And Chloe Martindale brought up the issue of cutting down and traveling to conferences. She mentioned this, I think, at the membership meeting yesterday. So to reduce our carbon footprint, and this might be a good time to have such a discussion. So I'd be happy if we can have that, open that up for discussion now. So also accountability. How can we ensure that problems get solved? Our ethics committee's good solutions. I know the IACR now has an ethics committee. What can we do that people will trust? So I think in the hope of getting a discussion going, I'm going to stop there and take questions. And let's see. So we have Reiner, who I can maybe unmute if you're willing to do that. And let me see, we have one more.
I will do this.
Great. Okay, so we start with maybe Reiner Broker if he's around and willing to be unmuted.
Yeah, so I know you're allowed to talk. You can talk, please.
Muted, I assume.
Yeah.
Okay, I assume that is a yes. So I wanted to bring up that sort of in between a proceedings volume and a math journal, sort of ends in the middle, in the sense that every paper gets refereed by 3 people and has a page limit and deadlines. So it sort of tries to do both of what I think, Alice, you were aiming for. I was wondering what your view on it was.
Yeah, so ANS, I will explain, is the, what is it? What's the A in ANS?
Algorithmic number theory?
Algorithmic, right? Algorithmic number theory symposium. Yeah, so algorithmic number theory symposium. And Reiner, can you, so how is it different from, Eurocrypt and crypto in terms of refereeing? I think of it as being pretty similar. So you do get several people looking at each paper for things like Eurocrypt, crypto, AsiaCrypt.
No, I haven't refereed for Crypto in a while, so I'm not quite sure what the differences are. Let me tell you how AND does it for the upcoming AND in July. Every paper gets refereed by 3 people with a deadline of like 6 weeks to referee the paper. I could be the same as Eurocrypt. I do not fully know. Let me make no claims about that.
Mm-hmm. Okay. Yeah. So the thing about ANTS is it does seem very similar to the Eurocrypt, the computer science model. Let's see. So Scott Fleur has a question. Is part of the difference between math and crypto is the speed of research? And I probably agree with you on that. I believe the more fundamental, well, actually, maybe we can unmute Scott and let him ask the question. If he's there. And maybe you can start by asking the question and then we can have the discussion.
Okay, can you hear me now?
Yes.
Yes.
Okay, yeah, basically what I'd like to comment on is that crypto really, as a academic study, started 45 years ago. Mathematics as an academic study, well, 2,000 years ago. Basically, we are crypto, because we're starting from we're a lot closer to the beginning, we move a lot faster. And so I suspect that's part of a lot of the reason why there's a far greater rush to get results out, because basically it's all fresh. Alice, do you agree with that?
I agree that it's much newer, and a lot of the differences in the two fields come about because of the fact that one is older and more traditional and more set in its ways in some ways, and the other's newer. I think also, I think there's a lot more money involved. There's a lot, higher stakes in cryptography. So, for mathematics, you're not going to make any money off of your math theorems. You're not going to have a product from it. And I think in cryptography, there's a lot more competition because there's a lot more at stake. There's more money, there are products.
Yeah.
So I think that a lot of it's that. I think people jumping on each other's work to try to get priority claims. Well, mathematicians, we're very gentlemanly, and we, sit around and take forever. And we think that if we give a talk and announce a result, that we then get to write it up at our leisure. And then we find other people start, working on it. And in math, that's not done. In cryptography, that is done. So yeah, I think the differences in the field, the fact that the age of the field makes a big difference. A lot of so it'll be interesting to see what happens as the cryptology community ages and matures. Does it go in good directions or bad directions? Does it take the good things that happen in mathematics, or the bad things? And so I'm wondering, should we move in the direction of trying to get the papers right? Even if it's quick, can we get both? Can we make the publication fast and also have accuracy?
Yeah, just accuracy basically means heavy review, and heavy review takes time.
Right, true. Yeah, so maybe we can get it to take less time than otherwise. Let's see. Okay, great. Thanks, Scott. So there's another one on Andrea Ferretti. Do you want to be we can maybe unmute you and you can ask your question.
No, sorry, it was just a comment on the previous question, not a question. Sorry.
Okay, yeah, so I guess there's a question about a lot of the advancements in crypto have been done in the last 10 years, and math is more like the last 100 years. Yeah. And let's see.
So Alice, just a comment. I think there's a major difference between publications in math and in crypto. That's the fact that in mathematics, when we publish, we have usually several iterations between the authors and the reviewers. And so this allows to correct typos and so on, and to make several modifications, where when it's very difficult to have this for cryptography conferences. And so this also explains why in cryptography conferences, we have sometimes papers submitted to Eurocrypt, and then it's rejected, and then moved to crypto, and then moved to EnsureCrypt, and then it's sometimes accepted after 3 iterations. And at the end, well, it was read by like 9 or 10 reviewers. And so because of that, what we did in the symmetric crypto community and in the chess community is that we now use a kind of a hybrid model where we have this type of publication like in the journal with iterations and so on, and we have a conference every year where all these papers published in the journal are presented. So what do you think? Can you comment on that? Or
yeah, so say that again. The what's the model now for that?
So the model is that we have a kind of journal publication with a deadline, but where we have some revisions of papers. So which means that your paper may be not accepted as it was submitted, but the authors are usually requested to modify, to make some modifications.
Yeah, I guess for me, the question is, what are the quality of the papers that are actually published? So for me, I'd like to see polished, well-written papers, at the time of publication. So it's a question of, if there are deadlines, then I always start saying, oh, okay, so how does, what does that deadline do? Is that lower the quality of the publication or not? So if the papers are correct, clear, and well-written, I think that's great. Yeah, so it depends on what happens in terms of what actually gets published. So I'm suggesting, let's make sure the papers are right, give it as much time as it takes for that to happen, and maybe do things that would encourage that to happen more quickly than it does now. Does that sound, I don't know. So it depends on how that particular, how successful is it? And I guess I'd have to look at the papers to see.
Okay, so we have also a question about a suitable reward mechanism for reviewers. Do you have any ideas about it?
Yeah, so I was wondering about, well, so there are various things you can do. So you can pay reviewers, and you could even pay editors. You could have an award. So you can have, an award for, each journal can have an award each year for best editor and best referee. And that way people can put it on their CVs, put it on your resume, and they can get credit for it. So if you're at a university, you can say, I got the award for the best referee for this prestigious journal. So things like that, I don't know, would that work? So that's just, I'm kind of throwing that out there. Would that be useful? What would be more useful for people? Money or awards, or is there something else we can do? And also, bad editors and bad referees, we should also think about, like firing bad editors that don't do their jobs. This would be something I would like to see, perhaps. So, some sort of accountability. And do people have comments about that maybe before we go on? Does somebody want to write in the Q&A that they'd like to say anything about that? Or
there
well,
is a
someone
comment
suggested.
There's a
somebody
comment about
says,
conferences that have awards for good reviews. Yeah.
Awards for good reviews. So what is PETS? Does anybody know?
Privacy-enabled technology or something?
Okay, yeah. So so awards for good reviews. And so does that work? How does that work? Does that work well? People who've seen things like that, is that presumably it can't hurt, I guess, right?
I think the top-tiered conferences and journals do not have rewards. Usually it's a reputation of reviewers. Usually it's junior researchers who want to make a good impression. There is somebody overlooking. I think the nice thing about the conference system is that you have, if you're a junior, you're a young person, you want to prove yourself. There's now, our committees are about 60 people can watch you. Most PC members, I mean, this PC excluded, but most PC members are lazy. And those who do their job, they get recognition in real time. It's a very effective way of getting a good reputation. If you find ways to improve papers you're reviewing, if you find bugs in papers, you get reputation points, and this translates in the long term to everything, to money, to good career. So the conference system has this advantage, this THIS advantage of giving a good exposure, not just to PC members, but also sub-reviewers who do a good job.
Let's see. So there's a comment, a mathematician is a device for turning coffee into proofs. The cryptographer is a device for turning coffee into arguments. So it's pretty intrinsic that cryptographers publish arguments about arguments, or let's see. So this is from Don Beaver. Do you want to be unmuted? We can unmute you and see what. So the verification.
The real Don Beaver. Hi, Don Beaver.
Hi, Don. You can speak.
Yeah, no, thank you for a great talk. The real comment here is it's partly facetious, but also partly not facetious. The idea is that cryptographers really are teasing apart the notions of proofs themselves, and on the level are engaging in a practice where you make arguments about these proofs, about these arguments themselves. So do you think that that's actually just part of the culture to say that, look, you know, it's impossible to get a perfect proof, or you live in a world where you have faith that perfect proofs are possible, and that's what you focus on. You dot all your I's, you have 0 mistakes in your papers, and you know, you follow some, you know, 2,000-year-old tradition of making sure everything is absolutely perfect. Because there's something intrinsic in these two fields where arguments are kind of good enough. If you've got a 99% sure statement that what you're talking about is true, then 99% is good enough. We'll keep building on that and build as far as we can with 99% verified things. Occasionally there'll be a 1% case where, you know, you'll find, you'll cryptanalyze something, it will break, and then you'll rebuild again from there. So this is intrinsic to the two fields.
Yeah, I agree that, you know, if you can build something and it works, that's a good thing. And if you can attack something and break it, you know if you've done that. And, you know, you don't necessarily have to write a proof of that. You can just do it. And I think you're right. There are things that are intrinsic to the field. I guess the problem is if you're trying to convince people that you have security, that your system is secure, and then I would kind of like to see a paper that's clear and well written and doesn't have mistakes and is convincing in some way before I feel convinced about the security. So it kind of makes me feel, you know, I get worried about the security when I get worried about the paper, and maybe other people are less worried, but you know, maybe this is my mathematical side being worried about that. But yeah, so certainly when you break something, you've broken it, and you can just, you know, show that in lots of ways. My internet connection is unstable. Let me know if I cut out. Yeah, no, good comment. Yeah, so I think there are intrinsic differences in the field. Let's see.
Yeah, maybe Evgeny, you wanted to say something about the best award. You can talk now.
Yeah, unmute Evgeny if you can.
Yeah. Evgeny, you're now, you can talk.
Oh, I was just saying that to me, the problem with reviewers is one, finding reviewers, especially for journals, is one of the reasons that I, disagree with Alice. I think journals have to either die or adopt to the modern ways. And I was just going to say that to me, the best reward for the reviewers community. That's why Facebook, people don't pay money on Facebook, but essentially they give the information for free because it until recently provides fun experience. So the closest to the fun experience for reviewers would be, I mean, payment could be one, but I'm not sure if it's a sustainable thing, and it's definitely not fun. But maybe conference reviewers with a lot of like back and forth discussion. To me, there's definitely more of the fun thing where you learn things from your peers, you impress your peers, so unimpress them could go both ways. So I think that's kind of the most fun, the closest to the fun experience we can have, and we can definitely improve it by also maybe putting authors in the loop, because very often people just get confused when a simple question to the authors. So a more interactive reviewing process, both among reviewers and the authors, I think would be fun. And then if we want to kind of keep this dinosaur around with journals to get like better correctness and so on, we could take the papers that were accepted through this fun interactive reviewing process to a journal with basically the same reviewers and maybe minor additions and expanding all the proofs. So there I feel like we can kill both bears, make it kind of fun and modern, and also have some kind of slightly better stamp of approval. But anyway, this is my view, and I know most mathematicians disagree with me.
Yeah, I like the idea. Let's do something fun as a way to reward, that just giving people money isn't a lot of fun. I agree. So if we can think of something, new and clever that we can do that people will get on board with, so come up with good incentives to get people to do the things that we want the community to do. I think that's great. Thanks. Let's see, we should unmute someone else. Maybe I'll let Anne and Yuval decide who should go next.
Yeah, we can just.
So we have several suggestions about disclosing the anonymity in some cases where reviewers find bugs and so on. Maybe they could be added to the covers, for instance, or maybe, well, at least we can change and replace as the usual sentence, we thank the anonymous reviewers by something with their names. Won't it be a kind of a way to reward people?
Right, yeah, so that would be a question of whether you'd have to start by asking the editors or program members would have to ask the reviewers, are you willing to have to lose your anonymity and to become public? But if because the reviewers are going into it with the idea that they're anonymous generally, but if the reviewers are willing to do that, I think I think that can work where the reviewers get rewarded. Now, a lot of this, we thank the reviewers, doesn't always mean we're really, really happy and the reviewers really did something good. I'm really worried that the reviewer is going to kill the paper unless I butter them up a lot. So it depends on what kind of thanks. You don't necessarily want to reward the reviewer for holding you hostage. So yeah, but if they really did do something positive, I think that would be a way to reward them if they did want to get some sort of thanks, or as somebody said, possibly. So in mathematics, that has happened where people do get co-author credit if they contribute enough. You go to you tell the author, here's what you can do to fix the paper or to help the paper or to improve the paper, here's a new theorem or whatever. And the author sometimes will say, hey, that's really wonderful. Is the reviewer willing to be a co-author on the paper so I can add it in? So that can happen. It gets tricky because, of course, the reviewers and the editors have leverage over the author. And you don't want to be in a situation where you're kind of forcing an author to do something that they don't think is fair. So I think everybody has to keep that in mind. Make sure you're doing it in a way that, that everybody's happy with. But yeah, I think that is a reasonable thing is, if somebody's doing a really good job, they could either get co-author credit or some sort of thanks in the paper. I think those are good ideas. Great, thank you. Let's see.
So a question by Handan, how can we judge a bad or good reviewer? Who is going to do it?
Well, I think for the reviewers, presumably the editors would be doing it because they'd have some comparison with different reviewers. So for a journal or for a conference proceeding, you could have the program or the editors do that because they could make the program committee members can make a case for here's how great my reviewer was, here's what they did, and the committee as a whole could decide who gets the awards in that way, and the same for an editorial board.
So we have a couple of responses to Scott's comment. Ritam, you're given now speaking permissions, you can talk. Ritam, Baumik? Yeah.
I was just saying that perhaps that would be an overstatement, what Scott said about there being not many fundamental advances in math over the last 100 years. because from what I understand from my mathematician friends, that math has completely changed over the last 100 years. I mean, if back then it was somewhat accessible to a person of science who was not necessarily a mathematics researcher, but now, I mean, if I look at a paper in complete theoretical math, in complete theoretical math, I'll probably not understand anything at all. Like I won't even understand what the research problem is. So yes, that would be an overstatement what he said, but yes, I agree with the difference in speed, but I think that's more because in math, you need to get a deep result to publish. And while in crypto, since there's a lot of applications, even small improvements or small results, which are not very interesting theoretically, but can have some practical implications, can be publishable.
Mhm. Yeah, thanks. Yeah, so I think there are some fundamental differences in the fields. Yeah, I agree with you. I mean, I think there was also a comment that, when you're comparing cryptography and mathematics, maybe you're comparing it to a subfield of mathematics would be a better comparison, somebody pointed out. And I guess I noticed somebody pointed out the Google Docs document that Nigel Smart and others put up. And I guess I had looked at that at some point. I think there are some really good ideas there about publishing in journals and incentives and things like that. So that's in the Q&A if people want to see that. You can click on that link. I think that's a good comment. Let's see, Daniela Michiancio, you had a comment. Can we maybe unmute Daniela about the incentives for reviewers? If you're there.
Yeah, Daniela, you can speak.
Yeah, okay. So yeah, it was just suggestion, not necessarily serious, but in terms of incentive for reviewers, I think that's something important. Some people put a disproportionately large amount of time and effort in doing that, and they hardly get anything from it. And it's hard to come up with something. So both the award and the other things that were suggested are interesting ideas, but I mean, you can find problems with pretty much everything. What I put up in the comments, perhaps jokingly, is what about if you put a lot of time reviewing papers, maybe you should wait less time before you hear back from your journal submissions. So there is a shortage of reviewers, so it can be harder for journals to review things timely, not necessarily because people are bad, but because conferences are already taking so much reviewing effort with the program committees that in cryptography these days range around 50 people. I think that's the average size of a program committee, and we have several conferences every year. And conferences come with a deadline for reviews, while journals do not. So it's very easy for people to get overloaded, and journal reviews going on a sort of a slow track. So perhaps that could be a way to provide an incentive and reward for putting time into reviewing.
And so what would the reward be then?
Oh, that your journal submissions are given more attention, so that you don't get to wait indefinitely because the journal reviewers are busy reviewing papers for conferences.
Mm-hmm. Okay, thanks. Let's see. So who else? We guess we're running out of time. We have maybe a couple more people could unmute it. I'll let you guys decide. Yeah.
We have many comments on about having longer conferences. I don't know if you would like to answer that. Maybe I think all had the comments. Or if you want to talk.
Yes, can you hear me?
Yes.
Yeah.
So I understand the importance of having longer meetings as well, because both for community-wise and environment-wise. But on the other hand, people who have small children, especially if their spouses work, it makes life a bit more complicated. For example, if I go for a conference for 3, 4, even 5 days, it's one thing with all the electronic communications these days, But if I leave for 10 days, which I did a few years ago, the situation is completely different, both emotionally for the kids and also mechanically, for handling all the small children. So I'm not sure that
Yeah,
we should
that's a good
completely
point.
forgo.
Mentioned that to me. Yeah, so there is, but also presumably fewer conferences would work well for you too, or because going very often is probably also disruptive for families, I would think, right?
That's true, and this is why I'm not attending all the venues I could attend, but at the same time, it's also a matter, it's not just a matter of frequency. For example, it's a close conference and it can go for 2 days, then it has significantly lesser impact, even if it's once a month. But it's a personal thing, of course.
Right, so that's why I was thinking about things like the Simons Institute for the Theory of Computing, where you have a semester-long program, people who can go on sabbatical and maybe bring their families with them, can be there the whole time. But then you also have these shorter workshops, and then other people can show up at the workshops. And again, if they need to, only for a few days, and maybe come as often as, as they can. But then you have the flexibility. You can decide, is it good for me to try to come for the whole semester, or should I just come for this one workshop or these 3 workshops? Or so I'm suggesting maybe some more flexible things, but things that build community more. So yeah, no, I agree that there are these issues, and we want to have enough flexibility that you're accommodating the people with families and people coming from very long distances. Yeah, I think these are all really important things to think about. Thank you. Yeah, do you have
Yeah,
suggestions?
we also have a.
Sorry, yeah, or do you have more suggestions about should we change the model, or are you happy with the way things are now? Or, oops, I guess you're muted.
Sorry,
Hey.
personally, I'm currently, I was educated into this system. So just like the journal conference system, I grew up in this system. So this is the only thing that I know, and I got accustomed to. And
right, and when you change, you never know, is it going to get worse or better? So that's certainly something to worry about. Yeah, Anne, do we have time for more, or I think have we reached the limit?
We have two more minutes.
Yeah, I'll give us a quick comment just about the SOK papers that you said.
Yeah, happy to make this suggestion that just came up as I was listening to Alice's very nice talk. Yeah, thank you for the nice talk. Other conferences, security conferences, have introduced this concept of systematization of knowledge. So basically what they do is that they sacrifice some slots on the main conference to incentivize people to write papers that systematize previous results. So basically, like, these are survey papers, but that somehow, like, they're more than just a survey paper. They just organize the previous knowledge in some way. And many people have found these papers quite useful. So in parallel to that, and in response to what you were saying about incentives and organizing mathematically better the past cryptographic results, we could also consider doing something similar. So sacrifice some slots and invite papers that do this mathematical systematization. So it's not new research, it's basically old results, perhaps results that have an impact in the field, but proven in a more elegant way, with perhaps new structures on the way that the proofs are organized, more readable, perhaps correcting minor subtle issues. So basically results that normally would not have been sort of incentivized to be done, but now because they get a slot, let's say in the main venues, people are more incentivized to write them.
Great,
That's
thanks.
a suggestion basically for discussion.
Yeah, good point. Anyone else have comments on that?
I have a comment, actually.
Kevin.
You've all rudely promoted me to be a co-host, and so I didn't have a chance to raise my hand or post a question because panelists can't. Like you, Alice, I also crossed over from mathematics to computer science and was observing the cultural differences between the two fields. The mathematics community has an annual meeting in January at which essentially all mathematicians would go to the same meeting. It's a gigantic affair. It has thousands of people present, and it forms a sense of community at that meeting that is somehow absent in computer science. There's no such thing as a global conference in computer science. We also have the International Congress of Mathematicians that, and I think it would be nice to have at least one meeting a year in which everybody goes. What I have found is that I don't have time to go to FSE and PKC and TCC and CHES because there's just too many meetings to go to and there's too much travel to do. I was president at the time that these smaller meetings were spinning up, and it was caused by the fact that our conference system was too rigid. We didn't want to have parallel sessions, and yet we also we wanted to have selectivity and the acceptances. And so there were too many papers being produced and they had to find an outlet. So they created a separate outlet, which was very much like the crypto, Eurocrypt, AsiaCrypt mode. But I think it's really time to rethink this and to try to form a better community among cryptographers and have fewer conferences. So I think there's actually some value in this. We used to have these artificial constraints that we had so many speaking slots in a week. We couldn't have parallel sessions, so we had a limit on that. We had a limit on page limits. If you remember, LNCS used to publish the volume of crypto and it was one volume, but it only got to a point where it was too big. And so, you know, we had to create 3-volume proceedings for the papers. You know, the journal would be mailed, you know, and somebody would hurl it into your driveway or put it in your mailbox. And, you know, the physical weight of the paper was a constraint. Those constraints should be discarded. They don't exist anymore. We should rethink this.
Yeah, that's a good point. I will say that I have been to crypto at times when it seemed like a really good sense of community. I would say more than the joint math meetings. But that's, you know, I'm thinking about a number of years ago. I don't know if that's changed now. Maybe we have too much now and it's lessened the sense of community at crypto and Eurocrypt and AsiaCrypt. So maybe we want to pull back and make those 3 the major ones to form a sense of community with an idea that we all go to all, you know, as many of those as we can, or at least the closest ones of those. What do you think about that, Kevin, with that?
I think that would be a good place to start back to, but we also, computer science has this idea that a paper is a talk, and those are 2 things that, you know, a talk at a conference is a paper. And in mathematics, that's completely ridiculous. If you go to the math meetings, that's not a publication. You know, giving a talk there is not a publication. That's completely disjoint. A publication is something that happens separate from your talk.
Right, right. Yeah, so what do you suggest, Kevin? Should we pull back from
I believe that we should move a bit more toward virtual conferences, and I believe that we should eliminate this restriction on parallel sessions. We have parallel sessions now, but they're not even in the same city, right? That's not healthy for the community. When the people who go to real world crypto don't talk to the people at TCC and don't talk to the people at FSE, for Christ's sake, then we know something's wrong.
Okay, on this happy
So maybe
note,
we can continue.
Yeah.
Maybe we can continue this discussion on Friday, because after the technical sessions, we will have 1 hour of discussion about open feedback and comments about the organization of virtual conferences and so on. So I think we will be able to continue this discussion. So we're running out of time. So I think we will stop here. We can continue also the discussion on the chat. So I would like to thank Alice for this very nice talk and for the nice discussion. So thanks to all of you for all these comments and questions. And so see you in 25 minutes for the ramp session. So thanks to all of you. Thanks a lot.
Thank all of you
Thanks.
for joining.
Apologies to all those who didn't get the speaking right. As Anne said, we will have another opportunity. And before the ramp session, we have the ICR Fellow ceremony, very important. So please stay tuned and join us in 25 minutes.
Thank you.
Thank you.
I think I start the next session.